So good afternoon, everyone. This is my PhD thesis, and today I'll be talking about carbon storage in the seagrass ecosystem along the Andaman coast of Thailand. As we all know, seagrass ecosystems in this region are highly affected by the coastal urbanization, overfishing, and oh my God, I'm sorry. So there was a problem this morning with my presentation, so it's going a little bit faster than it should be. So my apologies in advance if I go back and forth. There was coastal urbanization, exploitation over fisheries, and sediment runoff. So in turn, they are decreasing. Seagrass area, and with all. As we all know, the ecosystem services are decreasing, and carbon storage. As we are losing the seagrass meadow, we are losing not only the ability to accumulate and sequester carbon, but also the storage that has been stored in the sediment. So in the recent years, there's been increasing number of carbon studies in this region. However, we are still lacking. We are still falling behind by the other regions, and we are lacking by the global, the regional overview, as well as the factors which are influencing carbon. So the objective of this study is to see the overview of the carbon storage in several types of the seagrass meadow along the west coast of Thailand, and to determine whether geomorphological factors, disturbance, meadow type, influence any of these meadows. So the study sites were selected in 3 provinces on the west coast, in Phuket, Krabi, and Trang province. The meadows were selected, were divided into uniform and mixed meadows. Uniform meadows consisted only on Anhalus acoroides, while mixed meadow consisted of Anhalus acoroides and 1 medium-sized species. Further on, meadows were separated into high-density areas and low-density areas. Then they were divided into exposed and sheltered sites, were they facing towards the sea or they were facing towards the land. Also, they were separated into undisturbed areas and disturbed areas. Undisturbed areas were within vicinity of national park area, but while disturbed areas were around touristy or residential area. So in total, there were 16 surveyed areas. With combination of all these factors, there were 16 surveyed areas. So in each surveyed area, biomass and sediment samples were collected in rainy and summer periods with 3 replication per density. Biomass was collected from quadrat, and in laboratory it was separated into root, rhizomes, and leaves, and it was weighted, dried, weighted, and using linear regression between biomass and carbon in vegetation model, we calculated carbon storage within the vegetation. Sediment samples were collected from 1 meter core, which was hammered into the sediment and then cut into 3 centimeter intervals. In the laboratory, slices were dried, weighted, and grounded, and using loss of ignition analysis and linear regression analysis between loss of ignition and organic carbon storage in sediment was calculated. So data was analyzed using ANOVA however, for biomass and organic carbon in vegetation, only 4 factors were included: disturbance, season, geomorphology, and meadow type, while for organic carbon in sediment, all 5 factors. Also, variations within meadows were represented via maps, where biomass, organic carbon in the living vegetation, and total organic carbon storage in ecosystem is presented. So total average biomass was higher in the uniform meadows. In the uniform meadows and in mixed in all of the treatments. Root biomass, rhizome biomass followed the same trend. However, leaf biomass was higher, was very similar between uniform and mixed meadows in most of the treatments. In the overall map and the trend of the biomass, when we look at the maps, the higher biomass areas, which are darker blue, were in the areas where uniform meadows were, and lower, which are a little bit lighter, greenish. were in the areas of mixed meadows or around the edges. So the biomass was highly affected by disturbance geomorphology, where undisturbed sheltered meadows had higher values of biomass than other meadows. Also, total biomass and rhizome biomass was highly affected by meadow type, where undisturbed meadows had higher values than mixed meadows. Leaf biomass was affected by geomorphology, where exposed meadows had higher values of leaf biomass than sheltered meadows. So organic carbon in vegetation had a similar pattern as the biomass, where it was higher in the uniform than in the mixed meadows in all of the treatments for total carbon in vegetation, as well as in carbon in roots, rhizomes, and leaves. It was similar in all of the treatments. When we look the map, the overview map of the organic carbon in vegetation, it had the same pattern as in the biomass, where the higher values, which are yellowish, were higher in the areas where uniform meadows were, and lower pink color and purple are where the mixed meadows were and around the edges. So organic carbon vegetation was same as the biomass, affected by disturbance geomorphology, where undisturbed sheltered meadows had higher values than other meadows. Also, total organic carbon in vegetation, as well in rhizomes and leaves, was higher in the uniform meadows than in the mixed meadows. Carbon in the roots was also affected by meadow type geomorphology, where uniform sheltered meadows had higher values than any other meadows. Organic carbon in the sediment, it was similar pattern again, where it was higher in the uniform meadows comparing to the mixed meadows in all of the treatments, with the highest one recorded in uniform undisturbed sheltered high density area, and the lowest was in mixed disturbed sheltered low density area. Organic carbon in the sediment was mainly affected by disturbance, where undisturbed areas stored much more carbon than the other meadows. Further on, it was affected by meadow type and geomorphology, where uniform sheltered meadows had higher storage than other meadows. So the total carbon storage in the whole ecosystem followed the pattern that it was higher in the uniform meadows than in the mixed meadows. It was higher in undisturbed meadows than in disturbed meadows. And that, however, between exposed and sheltered meadows, there were very similar values. So the total carbon storage in the ecosystem, so that means that is including carbon storage in the sediment and in the living vegetation, followed the similar trend where the highest values, which are blue, were in the areas of uniform meadows, and lower values are yellow, were in the areas of mixed meadows or around the edges. So the biomass, as we said, the biomass was highly affected with the meadow type, which was expected, as uniform meadows consisted of larger species, larger, more constant, and longer living species, and with higher productivity, while mixed species consisted of larger plus the smaller species, which have lower productivity. However, disturbance geomorphology also influenced biomass, with the areas that have lower wind. With the areas that have lower wind, lower wave, and lower currents and limited human activity increase the biomass. So organic carbon vegetation has similar pattern in the biomass, as the biomass and the organic carbon in vegetation are highly correlated among each other. So it was affected by the meadow type and disturbance geomorphology. As these meadows can retain more sources and increase the rate of carbon accumulation and sequestration. Apologies. So the average recorded value for the Southeast Asia is 23.6 megagrams per hectare. And however, from the other reports, it is highly variable, and the sediment in our study fits among these values in the higher upper end. So we said that it was affected by the meadow type, which is supporting that uniform meadows store more carbon than the mixed meadows, which supports other studies. However, in Thailand, it was also recorded that uniform and mixed meadows store similar values, but also that mixed meadows store more carbon than uniform meadows, suggesting that structural complexity increases carbon storage. So we can conclude that morphology of the species and species composition highly affects the carbon storage. We also said that disturbance geomorphology influenced organic carbon storage with undisturbed sheltered meadows had higher values. So these areas have less influence of abiotic factors, where there is less influence. My apologies. Less influence of abiotic factors such as strong winds, currents, and waves, so they can promote higher content of fine sediments, particles, and larger organic carbon deposits. But also there is limited human activity in these areas, which increases carbon sequestration and storage capacity. However, seagrass density did not influence carbon storage, which was a little bit unexpected, as low density areas have less species coverage, higher patchiness, and more edges, which lowers trapping and accumulating capacity. But while high density areas have higher species coverage and they're more continuous, and they have greater capacity to retain carbon and accumulate more finer sediments. So in conclusion, in our study reported carbon storage in Southeast Asia going more towards higher end from here to here. The carbon was mainly influenced by the meadow type and disturbance geomorphology, and the variations of biomass, carbon in vegetation, and carbon within the whole meadow follow the pattern that it was higher in the areas of uniform meadows and lower in the mixed meadows. Thank you.
Okay, we have time for some questions. Yeah.
Can you hear me?
Yes.
Yeah. So before I want to ask my question, I want to make it clear because you had one uniform meadow with the big seagrass and the mixed meadow considered two species of seagrass, which is the big one and small one, right? Mm-hmm. So I'm missing in the study that is there uniform meadow with the small one?
No.
Okay, because it's very obvious when you have a big seagrass, you will have more biomass and more blue carbon. Then.
Yeah, but also as I said, there were reports that mixed meadows store more carbon than the uniform meadows. So the reports vary.
Yeah, because I am thinking that that will make your result much stronger if you have another meadow with small uniform seagrasses and put inside your study to compare.
For preliminary study, we did meadows with different sizes of the species. So we did Enhalus, we did Thalassia, and we did Halophila, and then we calculated carbon in each of the studies. But because of my whole PhD is focusing on the modeling and mapping, we couldn't do for the smaller species because they cannot be mapped properly because there's a high error of that. So they had to be a little bit eliminated from the study.
Thank you very much.
Oh, thank you. It's a nice stochastic sort of statistical approach. But my thing is about always implicit assumptions. It's the way I work because it's new and it's easier to get there in research at the beginning of something than later. Is one of the implicit assumptions that maybe within the study, you're looking at carbon stocks to a certain depth, there's a time function there. Do we have any sense from aerial photographs or whatever that the meadows were the same size or the same species over time?
No, we don't. I don't have the record from the previous years. However, for the future reference, for one study, we are looking for like going back to see how big was the meadow.
Also, species composition may change also.
Yeah, but most of these meadows have been there for quite a long time. So.
Quite a long time.
Yeah. I'm not sure how long, but.
Yeah. But it's an assumption that most of us have to make most of the time. Yeah, that's great. Thanks very much, Melissa.
Thank you.
Please join me in thanking Melissa again.